In this question, we have a particle of mass m projected along a smooth horizontal surface with initial speed 10. There is air resistance to motion of magnitude 1/3 mv, and v is the velocity of the particle. No other forces act. Find velocity after 3 seconds. So velocity and time. So we're looking at dv dt, velocity and time. So we know that v is equal to u plus at, dv dt is just equal to a in this case. Now we have forces going on here. Force is equal to ma. The only force at play if the particle is going in this direction and the force is against it, we'll say the force is negative. The particle is positive, but there's no forces acting in this direction, so we just have minus the resistance is mv/3 is equal to ma to set up our acceleration, so we can use dv dt. Dividing by m, we're going to get minus v/3 is equal to a. So now we can say dv dt is equal to minus v/3. So isolating these, we want velocity after 3 seconds, so we want time on its own. So let's factor out the third on the right hand side, minus 1/3, multiply across by dt, and then divide across by v, so we get dv over v equals minus a third dt. And if we integrate these, now the initial velocity was 10, so that's my initial, and then we're finding velocity at any time. So time starting at 0 and time. So on the right hand side, we're going to get minus a third t, minus 1/3 t between t and 0 equals, on the left hand side, we're going to get the natural log of v between v and 10. So we're going to get the natural log of v minus the natural log of 10, or log to the base e, is equal to minus t/3. So we're going to get the natural log of v over 10 is equal to minus t/3. So e to the power of minus t/3, e to the power of minus t/3 is equal to v/10. So actually I multiply across by 10, save myself a step. 10 e to the power of minus t/3 is my velocity. And we're asked for velocity when t is equal to 3. So 10 e to the power of minus 1, which is equal to 10 over e. And if we want that decimalized, this velocity would be 3.6787, 3.68, we just round it off here, 3.68 meters per second. Now, what else are we asked? We're not asked anything else. What else can we do with this? We have a velocity here. Let's just have a look. This will set up the next few questions. Velocity is equal to 10 e to the power minus t/3. What else do we know about velocity? Well, s is equal to ut plus a half at squared. So if we want the distance of this particle at any time, we need to use the s dt. So the s, distance and time, is equal to u plus at, which is my velocity. So I can change this velocity down here into ds dt is equal to 10 e to the power minus t/3. So this is how we get displacement in time. We've just dealt with velocity in time. So now if I want displacement at any time, ds will be equal to 10 e to the power minus t/3, or minus 1t/3. We're going to divide by that third now in a minute, dt. And integrating these guys will give me distance at any time, or the distance traveled by the particle at any time. So starting from 0, integrating the left, we're just going to get s, or s minus 0, equals, integrating the right, 10 divided by minus a third, is going to be minus 30 e to the power of minus t over 3. And that will be between t and 0. And 0 will give me a value here because e to the power of 0 is 1. So we're going to get minus 30 when we put 0 in. So displacement at any time is minus 30 e to the power of minus t over 3 minus the minus 30 e to the power of 0, which is just equal to 1. So displacement at any time is minus 30 e to the power of minus t over 3 plus 30. So you can sub in any value there and you'll find the displacement at any time. And that should set us up for the next series of questions.